I'd like to go over sections 13.2 and 13.3 from the book. The first thing we're going to talk about is converting between radians and degrees. They're both ways of looking at the measurement of an angle. There are 360 degrees in a complete circle, and there are 2 pi radians in a complete circle. And you can set up a ratio where 180 degrees is equal to pi radians. So what you're going to do when you're converting from degrees to radians, if you know how many degrees they are, for instance in this example right here, it says how many radians are in 150 degrees. You write down 150 degrees equals, you can use an X, I just use a question mark radians, and then you write 150 degrees as a fraction, which is 150 over 1. You multiply, since you have 150, since your units in the numerator is degrees, and you want to get rid of degrees, and you want to end up with radians in the numerator, you're going to multiply by pi radians over 180 degrees. Since pi radians equals 180 degrees, really you're just multiplying by a form of 1, because anything divided by itself is 1. You want to get rid of the degrees in the numerator, the degrees go in the denominator. You'll end up with radians in the numerator, which is where you want it. So you make it all into one fraction, 150 degrees times pi radians over 180 degrees, because 150 degrees times pi radians in the numerator becomes that. And then 1 times 180 degrees is simply 180 degrees. Then you can cancel out your degrees in the numerator and the denominator, and you have 150 divided by 180. They can both be divided by 30. You're left with 5 in the numerator and 6 in the denominator. It simplifies to 5 pi radians over 6, or 5 pi over 6 radians, which you'll see if you follow this arrow, is 150 degrees equals 5 pi over 6 radians. To go the other way, if you know the amount of radians and you want to figure out the amount of degrees, then you instead of multiplying by pi radians over 180 degrees, you multiply by 180 degrees over pi radians. So if you're given 2 pi over 3 radians and you want to figure out the number of degrees, you simply take 2 pi over 3 radians, multiply by 180 divided by 180 degrees divided by pi radians, write it all as one fraction. You get 2 pi radians over 180 degrees divided by 3 pi radians. Your pi and radians will cancel. You'll be left with 2 times 180 degrees divided by 3. After you simplify that, 2 times 180 degrees is 360 degrees. Divide that by 3, you get 120 degrees. If you follow the arrow, the dotted red line, you'll see that you have 120 degrees equals 2 pi over 3 radians. Next, we're going to talk about the unit circle. The unit circle is simply a circle with a radius of 1. You can make triangles, and in our case, we're going to make special right triangles, where you have 30, 60, 90 right triangles that are formed, or 45, 45, 90 right triangles that are formed. And we talked about the ratios of the sides in the past class. If not, I'll review it when I come back to class, but I'm going to make the assumption that you know that. If you form a 30-degree angle, and the angles are always formed starting with the right side of the x-coordinate and the hypotenuse, and you always move counterclockwise. So if I start from the right side of the x-axis and I move up 30 degrees, I form a right triangle, and this angle is obviously 30 degrees. We make a right angle where the x-coordinate meets the y-coordinate, and then where it meets the unit circle, that's a 60 degree angle. So we have a 30-degree angle here, 90-degree angle here, and a 60-degree angle here. The x-coordinate is always going to be on the x-axis. The y-coordinate is always going to move from the x-axis either up or down. So in this case, if you have a 30-degree angle, since opposite the 30-degree angle is 1/2, the y-coordinate is going to be 1/2. The x-coordinate is in this case, it's going to be the square root of 3 over 2, because that's opposite the 60-degree angle. And the hypotenuse, again, is 1. If you have a 45-degree angle, which you can't see is very faint, but there's a dotted line there, you could form a right angle, and both the sides, the x coordinate and the y coordinate are both going to be the square root of 2 over 2. If we formed a 60-degree angle with the x-axis and the hypotenuse, then the angle that would be up here where the mouse is would be a 30-degree angle. Opposite the 30-degree angle is going to be 1/2. Opposite the 60-degree angle, which is going to be the y coordinate, will be the square root of 3 over 2. For what are called the quadrangles, the 0 degrees, the 90 degrees, the 180 degrees, the 270 degrees, and the 360 degrees, you just go by the coordinates. If you start here at 0, 0, and you move to the right 1, your coordinates are 1, 0. If you start at the origin and you move up 1 unit, your coordinates are going to be 0, 1. If you start at the origin and you move to the left 1 unit, which is the radius of the circle, you're going to have the coordinate -1, 0. If you start at the origin and you move down 1 unit, then you're going to have the coordinates of 0, -1. Now, the really easy part of this is that the x-coordinate is always the cosine of the angle. In red, you can see it in red here. The y-coordinate of that point on the unit circle is always the sine of the angle. So if we have, as is done in the example here, if we have a 30-degree angle, the radius of the circle is 1 unit. The y-coordinate is 1/2. The x-coordinate is the square root of 3 over 2. So you could say the sine of 30 degrees, the y-coordinate is 1/2. The cosine of 30 degrees, the x-coordinate, is the square root of 3 over 2. Now, if we went over to the other side of the circle and we formed a matching angle, where instead of going right for our x-coordinate, we went left for our x-coordinate, you know from your past history of graphing that when you move left from the origin, your x-coordinate becomes negative. So if we formed a triangle that was in this position here, we would have an x-coordinate of negative square root of 3 over 2. That would be the cosine of that angle. We would have a y-coordinate of 1/2, which would be our sine of that angle. Now, to figure out that angle, you start from the right side of the x-axis and you rotate counterclockwise. So you're going to rotate 90 degrees plus another 60 degrees, and that's going to be a 150-degree angle, which the corresponding radian measure is 5 pi over 6.